Climate change is the most pertinent threat to our planet's health. The debate on whether or not global warming is occurring has been settled. It is. However, many skeptics like to cite the fact that the Earth's temperature has not been increasing as much as climate scientists have predicted. They say that this is proof that climate change has slowed down or even stopped. Yair Rosenthal, a paleoclimatologist at Rutgers University, has explored one hypothesis explaining this phenomenon. His recent scientific paper, Pacific Ocean Heat Content of the Past 10,000 Years, provides evidence that the ocean has been absorbing most of this heat.
The work that we have been doing and the recent study that we published essentially demonstrate what theoretically most of us knew, is that if you have a climate change that takes place very slowly, the ocean can basically keep up with it and absorb a lot of the heat, therefore buffering, so to speak, or mediating some of that change. Now, what happened in the recent time is that a lot of the change that we see is very quick, much quicker than the time that is required from the ocean to absorb this heat. And the studies that we published just show that when you have climate change very rapid and significant as happened over the last, say, century, the ocean is too slow to respond. I'll show you one thing. You see just that you get an idea. A lot of the cores that we are taking in the repository are long cores, but the video that I'm giving you, that's what we are recovering. That is a small core. We know down here it's an ash layer that comes from the Tambora eruption. That's the year of the winter, or without summer as they called it. So essentially what you have here, this is 1815, 200 years of Earth's history that we can reconstruct the climate from those sediments. And what you get is essentially we slice it into sediment that looks like that. So you'll see the video. And those are samples, so each centimeter that we take here, in this case, represent about 3 years of Earth's history that we get.
When discussing an issue like the past changes in ocean heat content, Yair and I bring different perspectives to the question. Yair brings the perspective of a paleoceanographer who's going out there and trying to reconstruct what happened in the past from the relatively small amounts of evidence that nature has left behind that can be used to tell us what the climate was in the past. So in some ways, Yair is like a climate detective. He's collecting these clues about what the climate was like. And those clues are always incomplete. It's not the complete picture that we have from modern instruments of how the world works today. My perspective as a climate scientist and somebody who studies the physics of climate change is to try to constantly be thinking about mechanisms and trying to think about why ocean heat content might have varied.
So we take the ocean sediment, the sediment that we collect from the core, and we wash them here. So we deseparate them and wash them, and after that, after we sieve them, essentially we pick the individual fossils under the microscope, and those individual fossils, essentially called foraminifera, which is small tiny organisms living in the ocean, either at the surface or at depths, and we collect them and do the analysis on them.
Foraminifera are a form of single-cellular carnivorous zooplankton. They have external shells which collect food and absorb ocean elements in the process. This is what makes these seemingly insignificant creatures so important to climate scientists. By studying the contents of fossilized forams, researchers like Yair are able to reconstruct the contents of oceans past.
The accumulation of sediments and layers is like the layers of a tree. So a tree has annual layers. In the ocean, we get things that maybe 100, 10, 100, or even 1,000-year layering. So we can look at really long climate records. They operate a couple of different ships that go out, and the ships have a big derrick on them, kind of like an oil derrick for drilling. But the drill bits have been fitted in such a way that instead of drilling the sediment to put a pipe in, they drill it and the sediment comes up in cores. And so we do scientific drilling. We drill hundreds of meters below the seafloor and bring those sediments up. And then we have basically a layer cake of time, so we can look at climate over a long period.
The team traveled to the coasts of Indonesia to conduct this research. Along the way, they ran into some unexpected challenges.
You know, Indonesia is probably the most challenging places to do oceanography because of the politics. And since the Indonesian did not let American ships usually to work there, we had actually to lease a ship from them and rebuild it for research processes. It's an area that is full probably with natural resources like fuel and gas and oil, and they want to protect their resources. So they put some barriers on oceanographic research.
Cannonball!
Here, King Neptune baptizes his polywogs in a traditional ceremony for all seamen. Upon passing the equator, they become egg-pack shellbacks until the day they become chief scientists.
When papers come out, there is often strong and instant reaction from different quarters. And because climate change, at least in the public media, is often something that's regarded as controversial, you sometimes have people finding a new paper as a great subject to try to spin in one way or another. So from the people who are skeptical about the reality of climate change, one way they thought about Yair's paper was, well, see, there were these big changes in ocean heat content in the past, so just because it's changing now, that doesn't mean that it's the result of human activity. The logic behind that is not very strong. We know the climate system can change for a lot of different reasons, and that human activities are just one of the reasons. that climate can change. But that was the spin that you got from some quarters.
Reaction to Yair's work, like most climate science, has been dramatic. Another recent paper that he was involved in, rapid reductions in the North Atlantic deep water during the peak of the last interglacial period, is no exception.
From scientific point of view, climate is a highly complicated system because you have feedback that we don't necessarily understand. So we know what we are causing, we don't know what is the result. So one example to stopping the circulation, as we find in this study, was given by Hollywood in The Day After Tomorrow, that we are basically moving the planet into a completely new ice age.
Everyone should hang on to a rail, please. It's going up.
The issue is that it's a scientific question, but it's a scientific question that has implications for public policy. It's hard to think about how we could address climate change, in other words, try to reduce its magnitude in the future without having some kind of international agreements to limit the emission of greenhouse gases. And then that goes to our energy use, and energy use goes to economic issues. And so there are a lot of connections there that create strong feelings.
The National Climate Action Plan I unveiled will cut carbon pollution, protect our country from the impacts of climate change, and lead the world in a coordinated assault on a changing climate. To reduce carbon pollution, I've directed the Environmental Protection Agency to work with states and businesses to set new standards that put an end to the limitless dumping of carbon pollution from our power plants. We'll use more clean energy and waste less energy throughout our economy. To prepare Americans for the impact of climate change we can't stop, we'll work with communities to build smarter, more resilient infrastructure to protect our homes and businesses and withstand more powerful storms. And America will lead global efforts to combat the threat of a changing climate by encouraging developing nations to transition to cleaner sources of energy and by engaging our international partners in this fight. For while we compete for business, we also share a planet.
So I think, frankly, as a policy question, Chris, Holman Jenkins, Kim's colleague at the Wall Street Journal, put it perfectly. The only question is, how much money are we going to spend? And how much wealth are we going to forego creating in order to have zero discernible effect on the environment?
Argument because every proposal ever done, including the United Nations Kyoto Protocol, would not even detectably impact the temperatures, assuming you buy into their science.
We're not going to affect the temperature.
When we're talking about a climate bill in the United States, President Obama was going around telling people it'll keep the planet 4 or 5 degrees cooler for our grandchildren. His own EPA said it wouldn't affect global CO2 levels, let alone temperature. And if you actually do, right now the developing world's getting 1,000+ coal plants. There, 1.3 billion people don't have running water and electricity. If we actually go the route of trying to stop carbon-based energy, which has been their lifeline, which would lower infant mortality and long life expectancy, it would be the most immoral position you could take.
And this is a classic right-wing trick. You don't have to have facts. You just go on television and you say, no, not so. You gave me facts, I give you nothing in return, okay? I say, not true, blah, 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 blah. So let's look into the facts. Well, the National Oceanic and Atmospheric Administration put out a report, and they cited 300 scientists in 160 research groups in 48 different countries that all came to the same conclusion. Conclusion is the past decade was the warmest on record.
To some extent, I find the climate change debate is becoming almost theological debates like on religion. Either you believe in that or you don't believe in it, and that's not conducive to any intellectual or public discourse how to solve a major problem. But the responses to the paper, and I think the media and maybe the scientists contribute a little bit to the dramatization of this issue. The media itself is speaking on the most dramatic things, and I guess that's what sells newspaper. I like to look in a more optimistic way on the results, and I think what we are saying in this paper, that even if the circulation shuts off due to global warming, it doesn't do it permanently. So the system recovers, and that's, to me, somewhat good news.